Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 8 of Red Team Operations with Cobalt Strike, Lateral Movement. In this lecture, we will discuss how to abuse trust relationships within a Windows Active Directory environment to meet objectives on or take control of remote targets. We'll start out with a discussion of the Windows Enterprise, how to do reconnaissance in this kind of environment, and things you can do if you can authenticate as an administrator to a remote target. We will also talk about how to assume the identity of privileged users by loading their trust material into your beacon session. And we'll also discuss how to spawn a beacon payload session on a remote target as well. Here is the lateral movement process in a Windows network. Step 1. Find out which systems are available for you to attack. These are servers and endpoints within the same network. For each of those systems, figure out which accounts are the administrator accounts for those systems. Step 2. Use the trust material that you have on hand to authenticate as an administrator user to one or more of those target systems. Trust material are access tokens, password hashes, credentials, and Kerberos tickets. Step 3. Once you have authenticated to a system as an administrator user, you can use those rights to steal files, run commands, or execute payloads. Step 4. Use your new accesses to recover trust material and determine which systems you are able to move to next. Keep repeating this process until you end up where you need to be to meet your objectives. This is lateral movement. All right, let's talk about the Windows Enterprise. First, Active Directory. Active Directory is a collection of technologies to allow central management of users, systems, and policies. A domain is a collection of users and systems managed with Active Directory. You will hear me refer to a domain controller quite a bit. A domain controller is one or more systems within an Active Directory domain that authenticate the users and systems on that domain. The domain controller is the broker of trust. It is the most powerful system on these networks. Throughout this lecture, I will talk about a local user versus a domain user. A local user is a user who has an account on a specific endpoint or system. When you specify a local user in Cobalt Strike, you will either use a period as a placeholder for the local system or the computer name \user. A domain user is a user account on one of the domain controllers. This domain user can authenticate to resources within the domain. A domain user is specified as the domain name \user. A local administrator is a user with administrator rights on a specific system. A domain administrator is a user with administrator rights on the domain controller. And if you control the domain controller, you can control any of the systems that trust that domain controller as well. So if you are a domain administrator, you now have the keys to the kingdom, and you can do whatever you want to systems that you can reach that are joined to that domain. Let's talk about reconnaissance. In this lecture, we're going to cover 3 different ways to get the same information. We're going to talk about how to discover information about the domain and targets within the domain with Windows commands. We will also talk about Beacon's Net module, which is a collection of commands built into Cobalt Strike. And we will talk about PowerView, PowerView is a network situational awareness tool written in PowerShell and developed by, can you guess? Will Schrader. And to use PowerView from Beacon, you will need to import it with the PowerShell import command, and you can use the PowerShell or PowerPick commands to run a commandlet from PowerView. I also want to mention SharpView. SharpView is a .NET port of many of PowerView's commandlets, and you can use SharpView if you're not comfortable running PowerShell on your target. And I do want to point out that SharpView was developed by Steven Flores when he was at Tavora. So how do we use these tools to figure out which domain we are on? Within Windows, you can run the command netview whack domain. Within Beacon, you can do net domain from the Beacon console. And within PowerView, you can use the get net domain commandlet. How do we find out which hosts are domain controllers? Remember, the domain controller are those systems that are the brokers of trust in that Active Directory environment. Within Windows, you can run the nltest command with the parameter whack-dclist and the domain, or you can query the domain controllers group on the domain controller with the net group command. Querying the domain controllers group will give back the computer account names of the domain controller systems in this domain. For example, if my DC is called DC, the computer account name for it will be DC $. It is very easy to turn a computer account name into a host name, and that's why querying this group works so well for reconnaissance and discovery. With Beacon's net module, you can do net DC list, the domain name, or you can use net domain controllers to query the domain controllers group on the domain controller for that domain. Within PowerView, you can use the get net domain controller commandlet. If you want to discover which hosts are in the domain without scanning for them, you can use the netview command on Windows. Netview does rely on something called the computer browser service, and if it's not running, this command is not going to yield anything for you, so be aware of that. But an alternate way to get the same information is to do net group domain computers whack domain, and this will give you back a list of computer account names for systems joined to the domain. Within Beacon, you can do the same thing with its net module. Netview relies on that computer browser service, which may or may not be available. I'll be honest, it's 2019, and maybe when you're watching this video, much later than that, and the computer browser service is probably not available. It's a very, very old technology. But you can do net computers, and that will do the same thing as net group domain computers, but the net computers command will go a step further and try to turn the computer account names into IP addresses and populate Cobalt Strike's data model as well. Within PowerView, you can do get net computer, which I believe is the same thing as querying the domain computers group as well. When working with Active Directory, you're going to be dealing with three kinds of addresses. The net BIOS name for a computer, which is a bare name like workstation or workstation 1. You will be dealing with a fully qualified domain name, which would be something like ws1.corp.acme.com, and IP addresses as well. If you want to turn a net BIOS name into an IP address, use NSLOOKUP or ping the system with one packet. Here we are in Kali Linux, and let's take a look at some domain reconnaissance. I'm going to interact with my Jim Stevens beacon, which is in a medium integrity context. Let's go ahead and answer the basic questions. Which domain am I on? Which systems are the domain controllers? What systems are in this network with Beacon's net module? If we do help net, here's the help for Beacon's net module. These are all the different things it can do for us right now. Let's go ahead and do net domain to find out which domain we're on, which is corp.acme.com. Let's do net domain controllers to get a list of domain controllers by querying the domain controllers group on the domain controller. And we learned there's one domain controller in this network, and that is DC. By the way, if you click on this little thing that looks like a target, you can change the view to see the targets currently in Cobalt Strike's data model. And so we can see we have our workstation 1 and our DC. Let's do net computers to query the domain computers group and get a list of systems joined to this domain. And let that run, and there we go. Now we have more stuff in our data model. So that is a little bit of target reconnaissance using Beacon's net module. Now let me show you how to use PowerView for the same thing. Let's do PowerShell import. And we're going to grab it from the PowerSploit folder, recon powerview.ps1. And we're going to use PowerPick because in this demo, I disabled AMSI, something we talked about in the PostX lecture. And we're going to use PowerPick to run PowerView without bothering any antivirus. Okay, so let's do PowerPick. And let's start out with getNet domain, just to get that same information about which domain we're on. And when that comes back, you can see corp.acme.com, which apparently has a child domain. Ooh, interesting. And we get a little bit of information too about which system is our DC. One thing I really like about PowerPick, it is definitely a power user's tool because it gives back a lot of information. Let's try using PowerPick to query the domain controller. And we'll do getNet domain controller. And this should tell us about the DC. And there we go. Here's the information about our domain controller, including the operating system and some other information as well. And you can see that it's dc.corp.acme.com, which is correct. And of course, we can do getNet computer to get PowerPick's list of information about systems joined to this domain as well. Or in this case, just a list of systems. Still very useful. So that's the PowerPick way. What about the native Windows command built-in way? Let's try that out. Let's do run wimic computer system get domain. And we get back corp.acme.com. And let's find out the domain controllers for this domain with nltest. So we'll just do nltest whack DC list corp.acme.com. And spoiler alert, this command is going to fail when I do it, and I'll explain why. But let's try to run it and see what happens. And you see we get back an error 2. Ooh, what does that mean? Error 2 means that the file was not found. What I want to show you, coming back to our sessions table, is we are in a 32-bit beacon on a 64-bit system. I personally prefer to stay 64-bit as much as possible, but the Java update scheduler was too tempting, so here we are. The reason you're getting this error is because nltest only exists as a 64-bit binary. So we need to specify the full path to nltest to actually run it from a 32-bit context. So we're going to do run C Windows. Why am I doing C system? Ugh, it's late. C Windows sysnative nltest, and we're going to do DC list corp.acme.com. And there we go. We get back dc.corp.acme.com. So that's the nltest way. And of course, let's just do with the net command baked into Windows. Let's query the domain controllers group. And we'll query the domain computers group as well. And there you can see there's our DC from the domain controllers group and the domain computers group. Here are the computer accounts for the individual systems joined to our domain. So that is some basic reconnaissance. Next, I want to talk about administrator accounts. But before we talk about administrator accounts, I want to share a concept that makes a lot of sense when you think about it. In a Windows network, you can authenticate to a resource, and who you authenticate as is who, as far as that resource is concerned, you are. When you use Beacon on a Windows target, what dictates the credential material that is used to authenticate you to a remote target is your access token. We talked about access tokens when we talked about privilege escalation, and we stated that an access token is associated with your process, but your current thread could have an access token that takes precedence over your process token. That token dictates who you are on the local system and what rights you have when you try to interact with resources on the local system. Your access token also contains a reference to something called a logon session. This logon session has the credential material that is used to authenticate you to a remote target when you try to interact with it through a beacon. This behavior of access tokens and separation between token and logon session will become very important later when we talk about how to turn credential material or trust material into an identity. But for now, I just want you to be aware that if your access token has the material to authenticate as an administrator to a remote target, you are, as far as that remote target is concerned, an administrator. And why does this matter? It matters because an administrator-trust relationship, being able to authenticate as an administrator user, allows you to do things to that system remotely. For example, you can interact with shares that are administrator only. $C and admin come to mind. You can also schedule processes. There are a lot of things you can do just because they are things Windows allows you to do to effectively manage the system remotely. When thinking about administrator trust and authenticating to a system as an administrator, keep this in mind. There's the domain administrator, which is a user or users who can administer any system within the domain. That is a God level account. But you don't always need domain administrator to do lateral movement. Pay attention to the local administrators. A local administrator is, again, an account that can administer a subset of systems within the domain. They just need to be a member of the administrators group on that Windows endpoint. How do you know if your current identity, as dictated by your logon session and your access token or your Kerberos tray, is an admin as far as a remote system is concerned? Well, you can try to do something that only an administrator can do. And if you can do it, you're probably an admin. One thing I like to do is I like to list the contents of the $C share with the ls command in Beacon. That is one way to check if your current context is seen visibly as an admin. You can use PowerView to try to figure out where you might be a local admin. If you use the Find Local Admin Access commandlet, PowerView will find systems joined to the domain and try to touch each of them one by one in a way that only an admin can. And where the action succeeds, it will tell you that you are an admin on that host. Let's talk about how to discover who can administer a system. First, we'll focus on the domain administrators. Who are the domain administrator accounts? You can find this out by querying the domain admins and enterprise admins groups on a domain controller. I also recommend you query the local group administrators on the domain controller as well. You have two options to do this. You can use Beacon's run command to query these groups, and that will run the net command built into Windows. And if you do that, you will be emulating a Chinese APT actor from 10 years ago, and apparently that is all the rage now. Or you can use Beacon's net module. With Beacon's net module, you can do net group // target and then the group name. You don't need to quote the group name because Beacon's arguments are position based. If you get a hold of a domain administrator account, congratulations, you probably have the freedom of movement to meet your objective. But becoming domain admin is not necessarily the only path to meeting your objectives. You may be able to meet your objectives and spread laterally to where you need to go without ever escalating to domain admin rights. This is a good reason to talk about local administrators. A local administrator is an account that is a member of the administrators group on a Windows server or endpoint. That account may be a domain account. These domain accounts are identities that, if you have the trust material to authenticate as them, will let you administer those systems. The net module in Beacon can query local groups and users. So you can do net local group // target to find a list of groups, and net local group // target group name to query a group. If you query the administrators group, you will see which accounts can administer that system. PowerView has automation to help here as well. Use get net local group -- hostname target to find out which accounts are in the administrators group on a specific host. You can also use invoke enumerate local admin from PowerView to enumerate who are the local administrators on systems that you can touch. One thing I want to point out, it used to be that you could do this kind of query from an unprivileged context and it was no problem. That did change. With Windows 10 Redstone 1, which came out in 2016, and Windows Server 2016, the default state is to require admin rights to make this query. There's also a patch available to make it so admin rights are required to make this query on older versions of Windows Server and older versions of Windows. You will likely find some systems where you can do this, but be aware that over time, this visibility into who can administer what will go away. I do want to touch on local accounts that are in the administrators group on an endpoint and what you can or can't do with those. If you have a password or password hash for a local account, and you think that that same password or hash can be used to authenticate to another system because it has the same local account with the same credentials, here's what you need to know. If you have the password hash or credentials for the RID 500 account, that is the account with a SID that ends with 500. Normally, this is the built-in administrator account, but it could be renamed. If this account is not disabled, you can authenticate with it to a system and use that identity to do remote actions. If you happen to have credentials for a local user account that is an administrator, but it is not the RID 500 account, you are not going to be able to do remote actions with that particular account, except maybe log in via RDP if that's turned on. Let's take a look at account discovery. Here I am, same place we were just a moment ago. And let's do the PowerPick Find Local Admin Access. Let's see where our current user might be an admin according to PowerView. So we're running this commandlet, and we can see that our current user is possibly an administrator on the file server. Let's check. Let's do ls // file server. And we're going to just try to list the C drive. And if all goes well, we'll get a listing. And this means, yes, indeed, we have administrator rights on that system. Let's try this out on a system we don't have administrator rights on. Let's try it on the DC. And I just want to show you what things look like when they fail. And you can see we get back an error 5, which is access denied. So that is what we would expect. Why don't we query around for the different domain administrator accounts? Let's do net group, domain admins, whack domain, to see who is a domain administrator on the domain controller. And we can see administrator and SQL admin are domain administrators. Okay. Let's try the same thing with Beacon's net module. Let's do net group. And we're going to query the DC, dc.corp.acme.com. And we will put in domain admins. And we should get the same information back. And again, I'm just showing you 2 ways to get the same information. All right, cool. Now you saw a moment ago when we used find local admin access that we learned that we are an administrator on the file server. Why don't we take a look at who else is an administrator there? Let's do net local group. We'll do file server. Just use the NetBIOS name for now. And let's look in the administrators group to see who is an administrator on this system. And we get back that click all, what a hog, Jim Stevens, any member of the domain admins group, and of course the local account administrator are administrators on the file server. Awesome. Let's say you've identified a target, a system that your current identity has administrator rights on. What can you do with that? Well, I recommend that you resist the temptation to put a payload everywhere you can. That is not needed in offense. That is not playing the role of a sophisticated adversary. One of the things you can do is use UNC paths to try to reference files on this other host. For example, if you want to list the files in C:/foo on the remote host, just do a dir // host $C$ foo. If you want to copy a file from that remote host to your current host, you can do it. And if you want to create a shopping list of files, you can do something called a dir walk to list out all the files and paths on that system or on a C drive anyways, dump it to a file, and go shopping. So this is the idea of agentless post-exploitation. It's using your administrator rights on a remote system to do things to it without putting a payload there. Another really cool agentless post-exploitation technique is to use WinRM when it's enabled to run commands on that remote target. You can do that with PowerShell, invoke command, computer name, target, script block, and whatever you want to run. What's cool about invoke command is it will give you the output back as well. You can use PowerSploit to run Mimikatz over WinRM. Just PowerShell import the path to invoke mimikatz.ps1 and run invoke mimikatz-computer name, the target. One thing I should point out is that the Mimikatz in the PowerSploit repository today is likely very, very stale. So if you're working with up-to-date Windows 10 systems and 2016 server, you're definitely going to want to put a up-to-date Mimikatz DLL inside of invoke mimikatz.ps1. Also, this file is pretty big. It's big because it has both the 32-bit and 64-bit Mimikatz in it. I recommend you get rid of the 32-bit one to stay under Beacon's 1 megabyte limit when using invoke Mimikatz. Another personal favorite, and this is something I had mentioned earlier in this course, is DCSync. DCSync is a way to recover a password hash from a domain controller. or he can recover all the password hashes from a domain controller. The DCSync command in Beacon aliases to the DCSync command in Mimikatz. Let's take a look at Agentless Post-Exploitation. Jim Stevens, our current user, is an administrator user on the file server. Therefore, we can do things to it. For example, if we right-click on our beacon, go to Explore File Browser, we can open up the file browser in Cobalt Strike, and we're just waiting for that beacon to check in. And let's put in a UNC path to an admin-only share, such as $, and wait for our beacon to check in. And there we go. Now we can browse the C drive of this system without putting a payload on it. And we can do everything we'd want to do, such as upload files, download files, and just look around. So that's an example of using the file browser. Let's take a look at WinRM. I mentioned before that we could use invoke command -computer name -script block, and whatever we want to run to run commands and get output from a target system over WinRM when it's enabled. And that's what that looks like. Really cool because you don't need to put a payload on the target. All right, I want to show you some things with Powersploit as well, particularly invoke Mimikatz because I think it's really cool. I do want to make one warning though. The file server system is Windows 2016, I think. No, it might be Windows 2012. It's one of those. It's more modern than... Actually, why are we like guessing? I can just do invoke command onto the file server and run system info to find out. So let's do that. Then we'll get back to invoke Mimikatz. So we're waiting for system info to come back. Okay, yeah, so the file server is Windows Server 2012 R2. Okay, great. It is up to date, and we do have a 2016 server as well. That's the mail server. So that's all fun. But what I wanted to point out is that invoke Mimikatz will fail if you use the one that is in the master branch of Powersploit. And the reason is that Mimikatz has been updated and some conventions for injecting shellcode via PowerShell have changed as Windows 10 has changed. Right now, it appears that the Powersploit master branch is not actively maintained, but if you go into the pull request, you will actually find people have contributed updates and you can pull something down if you want to refresh your Powersploit a little bit. And that's what I did here. I actually pulled down a pull request with a new invoke mimikatz.ps1 so I could do this demo. All right, let's do PowerShell import. Powersploit, exfiltration, invoke Mimikatz. And we see that the script is too big. I expected that. So let's go ahead and edit it. And by the way, this is the pull request I had pulled down. But if you go to the Powersploit project pull request, you will see there's a request to update invoke mimikatz.ps1. All right, let's go ahead and load up this file. Let's find the x86 DLL. And let's empty out that string. Save the file. Let's come back over to Cobalt Strike, try to import the script, and it worked. And let's do PowerPick, invoke Mimikatz, -computer name, file server. And if all goes well, we will get back credential material from the file server without having bothered to put an agent on it, which is again something I think is really cool. And here we are. We're getting back a computer account. Ooh, look at that. A password hash for the domain administrator account. That will be very useful later on when we talk about pass the hash. So that is an example of using Mimikatz over WinRM. And that is agentless post-exploitation. Let's talk about how to populate your beacon session with trust material so that you take on the identity of another user when authenticating or trying to do something to a remote target. We're going to talk about 4 kinds of trust material: tokens, credentials, password hashes, and Kerberos tickets. One of the cool possibilities with tokens is that if you see a process running with a desirable token, you can steal that token from that process and apply it to your current thread, giving your beacon session that identity until you drop the token. How do you token steal in beacon? Use PS to list the processes. And if you want to steal a token, just do steal token, that process ID. If this succeeds, your thread will now have that access token, and any commands you run and any actions you take that touch that remote target will use the credential material in that token's logon session to authenticate with that remote resource. To find out the username associated with your current token, use getUID. To drop the token, use rev to self. This will drop the current token from your thread and have beacon go back to using whatever is in your process token. Let's take a look at token stealing. So I'm going to come over to the sessions table and I'm going to interact with the system beacon. So we'll right click interact. And I just want to demonstrate that I do not, in this context, have any rights to do something to another system. So we're just going to try to list the contents of the $C share on the file server. And you can see that that does not work. Now let's right click Explore Process List and let's see which tokens are available on this system. So here's our process tree. And of course we should be, I guess we're over here, but let's sort by user. And we can see a bunch of stuff running as Jim Stevens. So let's steal a token from Jim Stevens just to demonstrate token stealing. So we're just going to highlight Explorer there, hit Steal Token, come over to our beacon session, and you can see we've tasked beacon to steal the token from process 3716. We are now the user, Jim Stevens, and we know Jim Stevens can interact with the file server. So let's try it out. Do an ls on the file server, and there we go. We are able to list the $C share because we are currently Jim Stevens. That is our thread token. If we do getUID, you will see we are Jim Stevens. If we do rev to self and do getUID again, we're waiting for a check-in. We are the administrator account. And of course, if we try to list the contents of the file server, we can't because we no longer have Jim Stevens token, and therefore we cannot authenticate to that file server as Jim Stevens. So that's token stealing. Let's say you have credentials, a username and password for a user who can administer a target you want to get to. How do you use those? You can use the spawn as command in beacon to spawn a session with alternate credentials. We talked about that during privilege escalation. More likely though, you will probably end up using make token. Make token will make a copy of your current token and give it a logon session that is populated with the domain, user, and password that you specify. One thing about make token. This command will create a logon session with what you provide, but it does not check that username or password at the time you make the token. If the information is wrong, you will get an error when you try to do something to a remote target. Make token confuses a lot of people because one of the things you'll immediately notice is when you make a token as another user and run who am I, you're still you. And the reason you're you is because make token makes a copy of your current token and just gives it a new logon session. This is something built into Windows and it is very much by design. Windows does this to allow you to authenticate to a network resource that is not part of your current domain. In this screenshot, you can see I'm using run as whack net only to create a PowerShell window as the user administrator. In this PowerShell window, I type who am I, and I can see I am the user what a hog. That is my identity on the current system. But when I do invoke command, computer name DC, to run who am I on a remote system, I learned that I am the administrator user. This is because my current token says I am what a hog on the local system, but my logon session, when it's used to authenticate to that DC, says that I am administrator. And as far as that remote system is concerned, that is who I am. Let me show you how to use credentials with the make token command. I think make token is probably the most commonly used command in Beacon, especially when it comes to manipulating your identity. We'll do this from our Jim Stevens beacon, which is a medium integrity context. Now, if we try to list the contents of the $C share on the domain controller, you will see that that does not work because we're not an administrator there. But the domain administrator is, the administrator account is. So let's go ahead and try to make a token with those credentials. We'll do make token, corp, administrator, and we'll put in the password for the administrator. Now, let's try to list the contents of the $C share on the domain controller. But 1 second. You see the impersonated corp Jim Stevens, right? We're getting that back because make token, again, makes a copy of our token, but gives it a new logon session that has these credentials. And if we try to list the $C share of the domain controller, you can see that that indeed works. So that is an example of using make token to take on new credentials for interacting with remote assets. And of course, you can drop that token with rev to self. And if you try to list the contents of the $C share, you will find we are back in the same place. Another type of credential material that you'll often come across is an NTLM password hash. You can use that password hash to authenticate as a user to a resource in a Windows Active Directory network. This is called pass the hash. Beacon has automation to pass the hash that builds on top of Mimikatz. Do PTH, the domain / the user, and the NTLM hash. What this does is it will start a process with an access token that is populated with the username and hash that you provide, and Beacon will steal the token from that temporary process. A few things to know. This automation does run command.exe to pass the token back to your Beacon process. It also interacts with LSASS. It will both read memory from and write to the memory of the LSASS process. That means you need to be in a privileged context to use this particular command. I do want to point out that this automation does do its job. It works, but it is not OPSEC safe. As you can see on the slide, it runs a pretty weird looking command, and that is something that has been signatured in many products. If evasion is one of your engagement goals, do not use the PTH command. You can still pass the hash with Mimikatz though. Here's how to do that. Use the Mimikatz command in Beacon to run sacrosa : PTH, specify all the values, and do whack run with some sort of temporary process that you think is safe for your context. Then use steal token to steal the token from this new process. Your beacon will now have a token applied to its current thread that has a logon session that is populated with the username, the domain, and the password hash you provided. When you do things this way, just remember you're still interacting with LSASS, which is a dangerous activity. Let's take a look at pass the hash. Here is our system beacon. We're going to interact with it because we need to pass the hash from a system context. Let's go to View Credentials. And earlier, we ran Mimikatz on the file server system, and we were able to recover the domain account administrator, its password hash, and of course that's for the domain corp, which is our current domain. That's very fortunate because this is the hash we're going to try to pass. Let's come over here to our beacon, and let's try to interact with the $C share of the domain controller. I just want to prove to you that it's not going to work when I try to do this. Yep, we get back error 5, access is denied. All right, so how do we pass that hash? Well, we can copy these credentials to the clipboard, just hit copy. And we can do PTH and Control V to paste, and there we go. That is a validly formatted pass the hash command. One thing I want to do is I want to change the spawn2 value really quickly. We are in rundle32.exe, and that's because I did not edit my artifact kit to get rid of rundle32 for my service executables. That's my fault. But we definitely don't want to spawn the default rundle32 for beacon because that could create problems for us. I actually know it will because I actually got snagged when trying to do this demo before, so this is definitely a retake. So let's change my spawn2 value for any 64-bit processes to C Windows System 32 dllhost.exe. Now let's try to pass the hash. So we'll paste that command back in. By the way, you could go right-click, access, make token, and this would do the same thing. So either approach works. But let's hit enter. And if all goes well, we will get back our output for Sacrosa : PTH. Here are the parameters. And you can see that we are indeed running this kind of very odd command.exe recipe. And what this does is allows Beacon to steal the token from this temporary process. That's all that's happening there. All right, let's try to interact with the domain controller, the C drive. And if all goes well, there we go. We have passed the hash to authenticate as the domain account administrator to the domain controller system. That is pass the hash. While we're here, let me show you one other thing we can do because we do conveniently have a trust relationship with the domain controller. Let's run DCSync. Let's do DCSync, or let's do help DCSync first. Let's do DCSync corp.acme.com, and let's grab the password hash for the KerbTGT user. So we're just going to do a DCSync, and we're gathering one other password hash. And you can see that that worked. And if we come over to our credential model, we now have another password hash in our data model for KerbTGT. Perfect. We're now set up for our next demo. What about Kerberos? Kerberos is an authentication protocol where a client can authenticate to a server with the help of an intermediary server that both the client and server trust and have shared secrets with. A full explanation of Kerberos and how it works would really require for me, the presence of Lee Christensen or Will Schrader, and neither of them are here right now, and I really apologize for that. You're stuck with me. But what I want to say is that a Kerberos ticket is another piece of identity material that can be used to authenticate you to a remote system. And your Kerberos tickets are stored in a data structure associated with your logon session called a Kerberos tray. To see which tickets are in your Kerberos tray, use the klist command built into Windows. You can run that with run klist. To purge tickets, use the beacon command Kerberos ticket purge. This will empty your Kerberos tray. And if you happen to have a ticket file laying around and you want to inject it into your Kerberos tray, use Kerberos ticket use and the path to the ticket file on your Cobalt Strike client system. One place where I've used Kerberos tickets quite a bit in offense is generating a golden ticket. A golden ticket is a self-generated Kerberos ticket with domain administrator rights. You can create one of these with Mimikatz. Here's what is required. First, you need the candidate user and the fully qualified domain name of your domain. For example, corp.acme.com. You also need the domain SID. From the context of a domain user, do whoami whack user with beacon's run command, and that will give you back the user's SID. Drop the last number in that sequence, they're separated by dashes, and you will have the domain SID. You also need the secret that is used by the domain controller to encrypt ticket granting tickets, and that is the NTLM hash of the KERBTGT user. You can get this with the DCSync command or by running hash dump on a domain controller. Cobalt Strike does have a cute little GUI to generate a golden ticket. Right-click on a beacon, go to Access Golden Ticket. Provide the username, the fully qualified name of the domain SID, that KERBTGT hash, and hit Build. Beacon will task Mimikatz to build a ticket with this information and inject it into your Kerberos tray. I'd now like to show you how to forge a golden ticket, just to give you some familiarity with doing Kerberos stuff. We're going to work with the Jim Stevens beacon for this demo because this is not a privileged context. And first, let me try to list the contents of the fully qualified domain name of the domain controller, dc.corp.acme.com. We should get back an error 5. And of course, the same thing if we try to list the $share on just the DC by its NetBIOS name. And just want to prove to you, no tricky things happening here. All right, let's create a golden ticket. We need some information to do this. We need a KERBTGT hash for the domain corp, which if we go to View Credentials, we have, because I recovered that hash with DCSync when we were able to pass the hash. So that's important. And we need the domain SID. So let's go ahead and grab that. Let's do whoami whack user from this domain user context. And this is Jim Stevens SID, and this is the domain SID. Right-click copy. And of course, we need the domain, which if we do net domain, we'll get back corp.acme.com. And there we go. We now have everything we need to forge a golden ticket. Let's go ahead and do that. Let's right-click, Access Golden Ticket, and let's do the administrator user, corp.acme.com. I'm going to paste in that domain SID that we gathered from whoami whack user. And for the KERBTGT hash, if we press ... here, we get back a credential chooser that just shows KERBTGT users. Very convenient. Let's hit choose. We've got that. Let's hit build. And if all goes well, we now have a golden ticket for the administrator user injected into our Kerberos tray. And let's do run klist. And that's going to fail because we're in a 32-bit beacon on a 64-bit system. So let's do C Windows sysnative klist. And there we go. We can see in our Kerberos tray that there is a ticket for the administrator user. Perfect. All right, now let's try to do things to the domain controller. Let's do ls // DC C $. And it worked. I do want to share something that is a failure I'm not really able to directly produce right now, but is something that could affect your operations. And I thought it would be better for a demo. I do have my golden ticket. I am able to authenticate to the domain controller. But here, when I'm referencing the domain controller, I'm doing it by its NetBIOS name. And you can see that that will work in this particular case, and that's great. Now let me try the fully qualified domain name. And this should work as well. Now let me try the same thing by the IP address of the domain controller, which happens to be 10.10.10.3. We get back an access denied. What I want to point out to you is that how you address a target can affect how Windows tries to authenticate with it. So whether you use the NetBIOS name, the fully qualified domain name, or the IP address will certainly influence which kind of credential material from your logon session is used to authenticate with that target. So if you're in a situation where you expect that something should work and absolutely is not, try addressing the target by its fully qualified domain name. And if that's not working, try the NetBIOS name. Assuming your credentials are correct, it might make a difference in some tight situations. So far, I've taken you through how to discover targets, who can administer those targets, and how to repurpose credential material into an identity that your beacon will use to authenticate to remote resources. Let's talk about how to get remote code execution on a target. There are two approaches in the beacon payload. There is automation for lateral movement, and that is available through the built-in jump command. And there is also a bring your own weaponization approach with the remote exec command. Both are new in Cobalt Strike 4. Type jump in the beacon console to list your different lateral movement automation options. If you want to jump to a remote target, do jump, the module name, the target, and the listener. There are several built-ins, for example, PSExec to run a 32-bit service exe via a new service, PSExec 64 to do the same thing except with a 64-bit service exe, PSExec PowerShell, which will use a PowerShell one-liner to run the bind pipe stager regardless of payload via a new service, and WinRM and WinRM 64, which will both run a PowerShell script via WinRM that runs your entire payload. All of these options, with the exception of PSExec PowerShell, are stageless. One thing to note as well is that you can extend the jump command with new modules using Cobalt Strike's aggressor script. You have access to the jump command and its modules by right-clicking on a host, going to jump, and choosing a particular module, and that will open up this dialog for lateral movement. So if you prefer working through a user interface, you can do that here. Let's take a look at lateral movement. Let's jump over to the targets table. And I think the file server is a good candidate because Jim Stevens can administer that system. So let's go ahead and right click, go to jump, and let's do WinRM 64. We know WinRM is enabled on that system because we were doing things with WinRM earlier. And if we selected creds from our data model, Beacon would make token or pass the hash for us. But we don't want to do that. So let's check use session's current access token to skip that step. Now let's go ahead and choose a listener. I prefer the SMB beacon when doing lateral movement. And let's choose a session. We're going to launch this lateral movement attack from our Jim Stevens beacon. Looks good to me. Hit launch. And let's see what happens. Our beacon is checked in. And if all goes well, we will get a new session on the file server. And there we go. One thing I want to point out is when a host turns red with lightning bolts in the targets table, that means you have an access there, and that's what that means. Very much a holdover from Armitage, which is the predecessor to Cobalt Strike. And if we right-click, we can see our Jim Stevens star beacon, the star meaning administrator level access. All right, cool. Now let's go over to the pivot graph. That's that little icon right here. And we can see our file server beacon and our workstation 1 escalated beacon chained through our foothold with Jim Stevens. Now let's try one more turn of the crank. Let's go to Explore Process List on the file server. And let's see which tokens are available to us. By the way, here's where we live on the file server. We are in WSM provhost.exe, which is a child of servicehost.exe, all courtesy of doing lateral movement by WinRM. All right, let's sort by user, and we can see that the administrator user is logged on. So let's steal their token. We're just going to highlight a process, hit steal token. And if we interact with this beacon's console, we can see that we told it to steal token from PID 2000, which is this one right here. Cool. Now let's try to jump over to the DC. Let's see if we can list $C on the DC. And we can. Great. Now if we do jump by itself, we get a list of options to attack remote targets from Beacon. And this is the same stuff you saw in the jump menu: psexec, psexec64, psexec PowerShell, etc. All right, let's go ahead and try. We'll do psexec64. Why not? So let's do jump psexec64, the DC, and we'll do our SMB beacon listener. And what you'll notice is I was able to tab complete each of those parameters. And if all goes well, we should end up with a new beacon on the domain controller, courtesy of psexec64. And so that's what we're waiting on right now. And there we go. We now have an access on the domain controller, and that's an example of lateral movement again. Now let's talk about the bring your own weaponization approach. I am a big believer in bring your own weaponization. This is a way to have more control over the process and to better demonstrate to your customer how a thinking and adapting adversary may react to the security posture in their environment. How do you do lateral movement the manual way in Cobalt Strike? Well, first, establish a trust relationship with the target. That's everything we talked about with token stealing, make token, pass the hash, and Kerberos tickets. Pick what is going to work for your situation. Next, generate an artifact that you want to run on the target. Upload that artifact to your target, or put it somewhere that your target can reach. and then run that artifact on your target. The last step, assume control of your artifact. Let's go through these. When you generate an artifact, I recommend you use a stageless artifact. You can generate a stageless artifact by going to Attacks, Packages, Windows Executable S in Cobalt Strike. What type of artifact should you generate? I would use a Windows Service exe if you plan to create a service to run your executable. Use a Windows exe everywhere else, or get creative and generate a DLL or generate a raw position independent blob that you can embed into some other artifact and run in a creative way. What kind of payload should you use? For lateral movement, I recommend you take a look at the SMB beacon and the TCP beacon. The TCP beacon has an option that is both bind, where you connect to the beacon to assume control of it, and there's actually a reverse TCP beacon as well, which we'll talk about in the next lecture when we talk about pivoting. These are all really good options when doing lateral movement. How do you upload an executable? One way is to take one of the shares that are available and upload the file via that share. I used to upload a file to my current system and then use the copy command in Windows to copy the file over to the target. Many Cobalt Strike users like to open up the file browser and navigate to a share, such as $C or admin$, and upload the file that way. And that's fine. It means you're not putting the file on your current system, which is good, better OPSEC. You can also CD to the share path directly. You can do CD // host, $C, // Windows, // temp, and use the upload command. This works. If you do this, just make sure you change back to a normal directory before you run a program, because many programs will not run if your current working directory happens to be a UNC path. How do you run an artifact? Well, in the past, I would have told you to take advantage of one of the commands built into Windows and use those. You can still do that, but I also recommend you take a look at remote exec. Remote exec is a command in beacon to run a command on a remote target with a method. You can create new methods with aggressor script, or you can use one of the built-in ones. To see the methods currently registered in your Cobalt Strike client, do remote exec by itself. And to run a command on a remote target, do remote exec, method, target, whatever command you want. The three built-ins are psexec, WinRM, and WMI. Once your artifact is running, if it's an SMB or TCP beacon, use the link or connect commands to assume control of it. And once you've done that, congratulations, you have moved laterally. Let's take a look at the bring your own weaponization approach for lateral movement. Let's go to View, Targets, and let's pick something we haven't taken yet. I think the mail server would be an interesting target. And for this, let's go ahead and try to take it from, the DC, why not? Demonstrate another level of chaining. So let's interact with our DC and let's create or steal a token to establish a trust relationship with the mail server. Let's just verify that we can't do anything to the mail server by trying to list $C. Nope, we can't. That's good. All right, let's see if there's a token we can steal. Let's go to Explore, Process List, and we will sort by user. And yep, administrator is logged on. So let's steal their token. Come over here and let's try to list the $C share of the mail server. And that looks good. Great. Now we need to generate an artifact and put it on the mail server. So let's go to Attacks, Packages, Windows Executable S, and let's choose our SMB beacon as the listener. We'll do a Windows executable, 64-bit, hit generate, and we need to come up with a cool name. Let's use something cool like monitor.exe. Why not? And now let's go ahead and upload that to the mail server. I'm going to use the file browser here. And I like using the file browser over changing directory to a UNC path because I don't want to forget to change back. So let's just go to // mail, $, Windows temp. And we're just waiting for that folder to come in. And let's upload our monitor.exe. We'll sort by name. And there it is. Great. Now we need to run it. So let's come over here to our beacon console, and we will use remote exec. If we run remote exec by itself, we can see some different options to execute something on a remote target. Let's use the WMI option, and we will do remote exec, WMI, pick the mail server, and we'll run cwindows temp, monitor.exe, and let's give it some sort of cool looking but innocuous arguments. I think that looks okay to me. So we'll hit remote exec, and it looks like it ran okay. That's good. Now let's try to assume control of our artifact, and we'll do that with the link command to link to a name pipe beacon on the mail server. And we'll tab complete our pipe name. And if all goes well, there we go. We've taken control of the mail server. And that is the bring your own weaponization approach to lateral movement. You know what I love about demos? Everything always works because I got to practice it over and over again in ideal conditions where I control everything. Offense is messy, and there are a lot of factors that can affect whether or not something is going to work for you. And I just wanted to share one bit of caution as we close out bring your own weaponization and lateral movement. If you use DCOM, WinRM, or WMI to spawn a session, you will get a session on the remote host running with the identity of the user you authenticated as. Everything might be okay, and that's fine, but you might notice some weird behavior, and I really wanted to touch on that. First, if you try to interact with a remote target from this new session, you may notice that you can't. Authentication seems to not be working. That is because the context you're currently in has a logon session without any credential material in it. Use make token to create a copy of your current access token and populate it with credentials. You may also see, if you do make token or steal token, that you can't run processes at all, or that you get no output from processes. If that happens, inject to migrate to another process context, or use elevate service exe to run a payload as system and work to meet your objectives from there. The main thing I want you to understand is if you see this behavior, you're not crazy, you didn't do anything wrong, and after 8 years of developing this tool set, I still don't know what's happening here either. And here we are at the end of this lecture. I will say this has always been one of my favorite lectures, and it's some of my favorite material. I think lateral movement and the fact that it's even possible at all is just really, really interesting. In this lecture, we talked about the Windows Enterprise, and I gave you some vocabulary if you're new to this stuff. We talked about Reconnaissance, how to discover targets, users, learn about your domain, and to understand trust relationships. We talked about Agentless Post-Exploitation. We talked about how to use trust material to take on an identity of another user with your beacon payload. And we talked about different strategies to get remote code execution with beacon. This concludes Part 8 of Red Team Operations with Cobalt Strike, Lateral Movement.